One very common way that algebra and tables are used together is you'll be given a table and you'll be asked which of these algebraic expressions represents the data in the table. So what you have to do when you're solving for that is you look at your table. In the first line of your table, there are always going to be two different ways you could get from one side of the table to the other side. Now, since we read left to right, that tends to be the way that most people will look at it. So, getting from 1 to 10, what's one way you could do that? Well, you could say 1 times 10. That equals 10. Another way you could do that is saying 1 plus 9. That equals 10. You have two different things going on here. In green, you have what's called a multiplicative relationship because it involves some multiplication or division. In this case, we're going left to right and it's times. In the blue, we see an additive relationship. We're either adding or subtracting something. Now, in the first line, you need to be able to create both options, your multiplying or dividing option and your adding or subtracting option, because then for the next few lines, you're going to check them. So, in green, does 2 times 10 equal 11? No, 2 times 10 equals 20, so the multiplicative option is not working for us here. Let's check the blue. Does 2 plus 9 equal 11? Yes, it does. Great. In this example, we are adding. Let's just keep going to prove our point. 5 plus 9. Yep, that equals 14. Going from left to right, 100 plus 9. This box would be 109. Now, you can go both ways in a table. So we've been going from left to right, but in this line right here, you can see that we have something in the right and nothing in the left. So we are going the opposite direction. We're going to do the opposite operation, which means the opposite of plus is minus. So we're starting with 18, minus 9 is 9. So that's how we find what's missing in the left-hand column. The reason that I can call this an additive relationship, even though there's some subtraction going on, is because when we look at GEMDAS, we have our groupings, we have our exponents, we have multiplying and dividing on the same level, and we have adding and subtracting on the same level. An additive relationship uses both addition and subtraction. It just depends on which direction you're going. In this example, from left to right, we are adding, but if we go from right to left, we're subtracting, but it's still keeping that same relationship there. So now that we've figured out what's going on in each relationship, you have to write it as an algebraic expression. The great thing about tables is they already define your variables for you in the top line. Here it says hours are going to be represented by H, and money, represented in dollars, is going to be represented by M. So, I like to pick the direction that you were going more frequently. It seemed like in this table we mainly started right here with hours. What did we do to hours? Well, we added 9. Hours plus 9 is my algebraic expression, because I would take 5 hours, I would add 9 to it, and that would give me my answer in the same row as the 5, I'd get my 14. If you wanted to take this further, like when we will do equations in the next unit, you could say H plus 9, your hours plus 9, equals the amount of money that you made, because each of these would be in dollars. The nice thing about a table is since your units are already included right up here, you don't need to write dollar signs for each of these. But if I did ask you in a separate question, hey, how many dollars would you make in 5 hours? You would need to include your units when you circled that answer. So you don't need them in the table if you don't want to. You definitely should not have them in your algebraic expression, just your plain expression, but units need to be in your answer. Alright, that's it for one of these tables that happen to be an additive relationship. Let's try another one. some number of aliens have some number of legs. Maybe this one alien right here has 8 legs. 1, 2, 3, 4. It's like an octopus alien. 5, 6, 7, 8 legs on this alien. When you're looking at your first line, you need to go both ways. 1 times 8 equals 8. That would be our multiplicative relationship. Or 1 plus 7 also equals 8. You have to check both of them before you can decide if you are multiplying, dividing, or adding and subtracting. So let's go down to the next line. 2 times 8, does that equal 16? Ooh, yes it does. Just double checking because sometimes you won't see a pattern until a few rows down. Does 2 plus 7 equal 16? Oh, no it does not. We are not having an additive relationship here. We have a multiplicative relationship. Fortunately, I don't think we will ever require you to spell the word multiplicative, just be able to recognize it in a multiple choice. So here we have times 8. Times 8, this one is going the other direction, so the opposite of times 8 is divided by 8. 88 divided by 8 is 11. Notice in this table I go 1, 2, 11, 9. That's okay. They do not have to go in order. They are sometimes going to be scrambled. So make sure that you're checking every single one and that you're not following into just a pattern of being like 8, 16. Oh, next would be 24. Check your work. This one is going from left to right, so we're not doing divided, we're doing times. 9 times 8 is 72. Just double check. 12 times 8, oh yes, that is 96. So when you then find out what your relationship is, you have to include it with your variables. Aliens times 8 will equal the number of alien legs. Here are 2 options. You could write it 8x, or you could write it x8. One of these is acceptable and one is not. When we write algebraic expressions with multiplication, first of all, notice how I do not have a multiplication symbol in there. That x is representing the variable of number of aliens. It does not mean times. But since I know that a number snuggled up super close to a variable, a letter, with no visible symbol in there, I know that that means multiplication. This is the correct way to write it. In math class, numbers are more important than letters, so they should come first when you're writing a multiplication between a number and a variable. Think of it this way. If I tell you to draw me 8 groups of x, that might look like 1, 2, 3, 4, 5, 6, 7, 8, and in each group there's an x. I can draw that. I don't know yet what x is, but once I do, I could replace the x in each of those groups with whatever number it is and add them all up. If you write me this, you are telling me draw x number of groups and fill it with 8. I don't know what x is yet. How am I supposed to draw x number of groups? That could be 0 groups, it could be 1 group, it could be 1 million groups. Who knows? That is why this is the incorrect form for writing out your multiplication. Your numeric coefficient, your number, should always come before your variable when you are multiplying them. So here we would have had 8x, not x8. So, using your tables, you can write your own algebraic expressions, and they will either be additive relationships, which could have addition or subtraction, or they will be multiplicative relationships where they could have multiplying or dividing.